Yeah, I sent it.
Excellent. Let me have a look here.
So on yeah,
Yeah, sorry.
on the so let me know what it says on the first picture.
So your code. Delivery
Okay, so
vehicle, you're calling super, yeah?
yeah, so I just placed super there because I'm not entirely sure how to use it yet. But
Mm-hmm.
for the instructions of task 2, it says create a class called delivery vehicle. I did that. And then do the private attribute cargo list of type string and what's it? Num items of an int, which is also private. I did that. And then it says create a constructor. So I created a constructor delivery vehicle, and when I added the parameters, it shows an error by delivery drone in your code.
Ah, okay.
So as you can see, I commented out another piece of code where instead where I created the class saying delivery drone instead of
Mm-hmm.
delivery vehicle. So when I did that, then it recognized it recognized the
Yeah,
parameter.
yeah. So that is an error on my side.
So
It's
what?
supposed to be a delivery vehicle, not a delivery drone.
Oh yes.
Yeah.
So if I do that. I thought that because IntelliJ was telling me there shouldn't be delivery drone, there should
Yes.
be delivery vehicle. Okay, so now when I fix that, it registers the parameters and then okay,
Does it
so now
work?
there's no error.
Okay.
It shows this now. It's showing the I'll send a picture.
Go ahead.
Yeah. So as you can see now, when I fix it to delivery vehicle, there, can you see it as the parameter registration and max capacity?
Let me double check here. Yes. Yeah, that's correct. Yeah, so that's an error in the sample code that I gave you.
Yeah.
Yeah. Okay, I'll make sure to make an announcement of that. Just have a note. Okay. Yeah, so thank you for bringing that to my attention.
Register.
That was an error on my side. So I'll post an announcement after the lecture to make sure everyone gets it. All right, so I guess that's the first lesson for today. Never trust that everything I do is 100% correct all the time. You're welcome to raise questions and double check.
Yeah, I was going back and forth. I was like, no, sir won't give an error to us.
No,
Oh,
no, I'm not perfect.
yeah.
Yeah.
It's like I'm just glad I did double check with sir.
Yeah, of course. And I think, yeah, no one should feel, no one should feel like they can't bring up something like this with me. You're more than welcome if you sense I'm doing something incorrect or there's something wrong. Bring it up with me. I'm more than happy to
I see.
have a look at it. Yeah.
But I said, how did you know the error was delivery drone? Was it also because the code editor was telling you that?
Yeah, and it makes it's not the code editor. It makes sense that if you have so actually this is a good example. If we look at that code, let me get my stuff out here quick. I'll just draw it on the first slide. If you look at that code, in programming we talk about L statements and R statements. They just stand for left and right statements. So in the Java syntax, we have something like a type, right? The identifier for the variable, an assignment, then we say new, and then we have the same type again. Okay. So today we're going to cover something like this, and then we have the constructor with a semicolon. So this is the Java syntax in general.
Yes.
And what we can infer is that this type and that type have to be the same. So when I looked at that code and I saw a delivery drone.
Yeah, and also what I did on the PDF, I controlled F and I looked for everywhere delivery drone is, and I saw no way. And I was like, okay, yeah.
So that's also very good, using Control F to find things. So when we look at this statement, this is the left statement and this is the right statement.
Yeah.
Java wants to reconcile that the types work. And in this case, these types aren't the same to Java.
Yeah.
And then it can't find this class, so it kept giving you an error.
Yeah, so that's what IntelliJ was telling me. IntelliJ was telling me to create a class called delivery drone,
Yes.
which I did, and then it worked, but then it was saying there's an error with delivery vehicle.
Yes.
So that's why I was jumping back and forth.
Yeah. So this is the drawback of the type system. But in a programming language where it's not very strict on types, like Python might just interpret this and fail, and it will, you won't have this type.
Yeah.
And in Python, you would just be creating a delivery drone class.
Yeah.
So that's both the benefit of the strong type system in Java.
Yes.
And so today we're going to look at something where we can have something like this, where we have type A, our variable, and assign it to a different type. But there's a special rule that we're going to follow. And this concept here, where we have kind of a one type and we're casting almost another type into a variable, this concept is related to polymorphism, which we'll talk about today.
Okay.
Yeah.
I have one more question, but must I ask it after?
No, you're welcome to ask it now. Yeah.
I was saying, and for number 2, it says here that we have to, I see now we have to make use of the super constructor, which Sir spoke about yesterday.
Yes.
So basically, Sir's saying we have to put the stuff that's asking us in the super constructor itself, not like in the bracket or under it. Am I allowed to ask that question?
So that's the topic of today's lecture, so we might as well start.
Okay, cool.
Okay, so today we're looking at superconstructors.
Okay, cool.
Yeah.
Yeah, that's basically question 2 in task 2.
Exactly, yeah. So yeah, we'll do that. Then we'll talk about a little bit about encapsulation, because encapsulation is related to inheritance, and then polymorphism at the end.
Yes, sir.
Okay. All right, so we might as well begin. I'll just double check that the live stream is up. It seems to be up and doing fine. I'll open the chat here. We'll get started. So today we're going to talk a bit more about inheritance, specifically with superconstructors. And with superconstructors and inheritance, we're also going to talk about method overriding. So with method overriding, we need to be careful that we're not confusing it with method overloading. So the one is override and the one is overload. Okay, so these are not, they're not the same, these two. All right, so be careful when you're studying these things. And then we're going to talk about polymorphism closer to the end. We'll see how far we get. Polymorphism isn't a necessary topic to cover today, but I also don't want to leave it for tomorrow and feel rushed. All right, so if you recall, Monday. If you recall Monday, we had a person class, right? The idea of a person, and then from that person class, we extended it. So we created an inherited or a derived class from the person class, which is the idea of a student. So we had some sort of structure where we had a person as a class, and then a student as a type of person. And that's what this arrow means in a UML diagram, right? This arrow means that a student is a type of person, So the student also inherits all of the attributes of the person class and then can add its own attributes. All right. So over here for the person, this is the constructor. We're talking about how to create the object. Because we take no parameters for the constructor, it is the default constructor. It's good practice to always define your own default constructor. This is because when you have things like an array, Java won't instantiate arrays for you. So you will have to create the arrays yourself in a default constructor to give them an initial value. Then we had a private attribute for the name. And because this attribute is private, yes, on Monday we learned that you can't access private attributes from outside of the class, regardless of whether or not it's a derived class. So in the person class, we had the name, which was set to private. In the student class, we had a student number. But from the student, because the name was private, we were not allowed to access the name attribute. Okay, so that's what private means, and that's part of the encapsulation or information hiding for Java programs. Okay. However, we can use the getter method, which is a public method, to get the name in the student class. All right. So let's look at the student class. The key word here when we are creating a derived class is extends. A student extends a person. In Java, the rule is that a class may only extend one other class. So you can only ever have one class after the extends keyword. Later on, we'll look at something called a Java interface. This is different from something called a class interface. A Java interface is a special idea that Java introduces to get around this issue where you can only inherit from one class. Okay, don't worry about interfaces for now. We'll talk about those later. So in the student class, we have a private string student number. Because it is private, it's not accessible outside of the class. We have a default constructor. It takes no parameters. And then we call the constructor of the person class. So the default constructor of the person class, because we're not giving it any parameters. And this is equivalent to calling person. Okay, so just a quick recap. It's calling the person constructor, which is on the previous page, and it will set the name to some default value. All right.
So in this example, there's no parameters in the superclass.
Yeah, there's no parameters for the constructors.
Yes. And the student is a subclass of person.
Yes. So we
can say extends.
Yeah, so the keyword is extends. So the Java.
There's another keyword task which Sir wrote, because Sir said that delivery vehicle is a subclass of basic vehicle, and now you're making use of this extends attributing.
So the extends is the Java syntax. So
that means you're basically saying delivery vehicle extends the basic vehicle from the top.
Yes, yeah. So you would have delivery, right? Extends basic, and that's the syntax.
I feel like I'm giving out the answer, but it's fine.
Yeah. So this is the syntax. So the child. So there's many names when we talk about object-oriented programming. The subclass, right? The derived class even, right? Extends in Java. We talk about extends.
Is there any point like is it just to tell the class that hello, you're the subclass of this?
It's to tell the compiler. So so it tells the compiler that, hey, everything that the person class is able to do, the student is also able to do. It tells the compiler that the student is a type of person. We'll reach more information about that with polymorphism.
Okay.
Yeah. So in other programming languages, I think Python, you will say class, the name of the class, and if you're extending it, you will put the parent like so. So in Python, the syntax is a bit different. And I think with C++, it's class, name, and then parent. Right? So it's just a different syntax. So this is the Java syntax to use extends. Does that make sense?
Yes, sir.
Yeah, and you can see it's highlighted here, so it's a keyword.
Yes, sir. Yes, sir.
Yeah. So when I'm talking, because object-oriented programming is a paradigm, it applies to a lot of languages. When I'm talking in general about object-oriented principles, we'll often say subclass, derived class, child class, parent class, and so on, or superclass. When I'm talking about Java syntax, I'll use the keywords. Or at least the code will have the keywords. Okay. So with our student, oh, sorry, is there any other questions? Just check the chats. No, we should be good. Okay. So the student also adds additional behaviors or methods and an additional attribute for the student number. Now we then had a demo where we created a student class and set the name, which we can call because it's now inherited this. It's inherited set name from the person class, right? It's inherited set student number from the student class. Well, inherited, it has the student class. And then over here, say hello was also defined in the person class. Okay, so you can see how even though we don't have person anywhere in our code, the compiler knows that a student is a type of person and that it can bind to the methods that the person class has.
It only knows that because it's a subclass of it.
Exactly. So when we said extends, right, when we said extends and we compiled, the Java compiler went to look for whatever it extends and then compiled that as well and put that as part of the code.
Sir.
Okay, so now we're talking about superconstructors, right? We learned on Monday that a superconstructor can only go up to the parent. We can't keep going all the way up the ancestry, if you will. And so we also might want to look at what we do when there's parameters we need to pass on to the parent. So if we have a non-default constructor in the person class, we can say it takes a name, a string name. We use this to make sure that it's not ambiguous as to which name we're referring to. So now we have a overloaded constructor in the person class where we have the person, right, the default, and then we overload it by changing the type and number of parameters. So it is a person with a string name, right? So the method signature is different. And now we have overloaded this constructor to take a string name, which means we can have a different constructor in the student class. So with student, we now have the default. And we also have an overloaded version, which takes a string name and a string student number. Okay, so this is an overloaded constructor, and we can use the super that we have defined over here. Okay, so this is how we can pass parameters or initial values up to the parent constructors. Is everyone with me?
Not understanding what's a super doing? Is super just taking the string name?
Yeah,
Like what's it doing?
so super takes the string name and sets it. So I think, do we have a demo? So now we can create a new student, give it the name and the student number when we create it. So that's calling this constructor here. And then that constructor in turn calls this constructor here and passes the name along. So as opposed to us saying down in here, saying this dot set name, right?
Those two separate codes. Like, is the top code different to the bottom code or the joint thing?
Sorry, say again.
Is the code on top with the super different to the code at the bottom? Like, is it?
Yes.
Are you comparing two codes or are they joint?
They're separate.
Two codes.
They're separate files. This is person.java.
Okay.
And this is student.java.
Like, are you just comparing? Are you just comparing the two?
Yeah. So I'm showing you. I'm showing you that when we call this special constructor, this super right here, this method, is referring to this method in this constructor in the parent class.
Yes.
Yeah. So that's what I'm showing you.
Yeah.
Yeah. So that means we can now just call a single constructor without having to set the name, set the student number, and so on. It makes our code a little bit easier to read and a little bit cleaner. So if you had an assignment where you say had some derived class, you had a derived class and you need to pass constructor values to the class that it is derived from, say the base class, you might want to consider using a constructor like this. Okay. So we can leave out the default super in a constructor. The compiler will see that you're doing a constructor over here, like a default constructor, and it will see that it extends the person class, and it will automatically fill in the super call for you. However, it's better practice to be explicit and always call super inside a constructor. And typically, it is good practice to call it as the very first thing in a derived constructor. So that's the kind of a best practice thing. Over here, you can see I'm talking again about the superclass. In this context, the superclass refers to the person. Okay, it's literally what we're referring to when we say super. Is everyone with me?
So yes.
Okay, excellent. So this is also fine. You know, it'll just run. And what the Java compiler will do is while it's compiling, it will sneakily insert a call to super in here in the same way that if you didn't have a default constructor, the Java compiler will make a default constructor for you. However, it is very limited in what it can do. Therefore, it's better practice for us to be explicit and actually define our own default constructors than implicit. So we can also use this to call different versions of constructors from in our class. So over here, we have a public constructor, the default. It takes no parameters, and it says this.name is no name yet. Then we have an overloaded version where we've changed the type and number of parameters, and it sets it to whatever name we pass in. It'll set the attribute. Okay, so we can simplify this where instead of hard coding this kind of statement, we can do the following, where we call this inside the default constructor. And in this case, this matches this method signature over here. So we're supplying it with a string name, like a default name, and it'll call this constructor right here. Okay, so this is all part of something called the dry principle. Don't repeat yourself. You don't want to waste too much code. You can just kind of build default constructors. Is everyone with me? Okay.
Can you say one more time, please?
Okay, so in this case, we have a default constructor, but we've overloaded it to take a name parameter as a string, and we can actually call this method, the overloaded method, over here.
What do you mean by overload? You keep saying overload.
Yes, so overload, if we have a method,
yes,
right, and it takes no parameters, but then we want to have the same method name that maybe takes an extra parameter. So we'd have the same method name, but now we want to take a string as well, right? We want to be able to call it both with and without a parameter, but using the same method name. So if we do this, it's called overloading, because the same method name, it's the same method name, but it has different parameter sets. So there's one where it's nothing.
You're overloading it because you didn't give it a parameter in the first one, but in the second one, you're adding something.
Exactly, yes. So we want to leave it as default so that someone can create like an empty person.
Okay.
Right? So we have a default one. But then if you have all the data, you might want to create a person with a name.
Yes.
And so because we want both of these, we're overloading the method. It's the same method name, it's the same constructor name, but it has different sets of parameters.
Yes, sir.
Okay, so that's the idea. All right, now we're going to talk about method overriding. So now we need to be very careful about what we mean. Method overriding only applies when we talk about inheritance. In most other contexts, when you're changing the type or number of parameters, it's overloading. When we talk about overriding, we are not changing the type or the number of parameters, but we are changing it from what it is in a superclass. We are changing it in a subclass. Okay. So in the person class, we had this say hello method, which we could call on the student object because the student inherits all the methods of the parent, of the person. However, if we want to customize this say hello method for a student, we can override the method. So we replace it with a more specialized version of that method in the subclass. Okay. So we don't change any of the parameters. We just re-implement in the subclass. All right. So we can override a method in the superclass with a new implementation in the subclass. How does this look? This means that we are essentially replacing that method. There is a concept in programming called shadowing. Shadowing, it's a bit more of an advanced concept. It has to do with the idea of scope, and it's essentially like what can be seen at what point, right? So if you had a variable name, what variable is it blocking if there's a variable name of the same type? Don't worry about shadowing, it's not applicable to this course, but if you are interested, you can look at shadowing as a programming language concept. So in this term, what I want you to know is that method overriding lets you replace a method in the superclass, in the class above it, right? The class it's extending. It's different from overloading because we're not changing the method signature. And if you recall, the method signature is the name and the type and number of parameters. It is very careful. It's very easy to mix them up. a method can be both overridden, you can override a method, and overload a method. Okay, so it can be very confusing. Let's look over here. In the student class, we're going to implement our own. So, sorry, this should say student extends person, right? As we've been doing this whole time. And then we say over here, public void say hello with no parameters. So this is the exact same method signature as person dot say hello. Right? It looks exactly the same, but it's now in the student class. And we say, okay, hi, my name is this dot name with student number, this dot student number. Okay, so let's look at compiling student.java. Let me just go here. Right. So we have our person class over here. I'll just double check the chat quick. Yeah, we're okay. So we have our person class over here, and then we have student extends person. Okay, so this is the same, but now we are going to implement the say hello method. Just like we saw on the slides, we're going to implement this method. So this is the person class with the public void say hello, and then this is the student with a overridden public void say hello. Right, and then we have a demo class that just creates a student and calls say hello. All right, so if we try to compile the demo, which will in turn try to compile the student, but let's just try with the student first. We can compile the student class. Okay. Then, if we try to compile the demo, it also works. If we try to run the demo, we get, hi, my name is Jack with student number 12345. So what's happened here is that the student class, we have replaced super.sayhello. So actually, let's go like this. That's for a bit later. We have replaced the parent class with one in the subclass over here. And typically, we would want to be good coders and say overrides parent say hello. I think there's an annotation you can give, which is at override like this. Don't worry too much about annotations, but it's probably good practice to say at override whenever you're overriding something. So if we try to just compile and run, you can see we've replaced the say hello. And if I comment all of this out, right, so I've removed the implementation of say hello from the student, and we recompile and run, you'll see that once again we get the version in the person class. Okay, so that's how overriding works. Any questions?
Nothing on my side yet, sir.
Nothing on your side. Okay, good. So it's just fine if we have this .name, right? We get an issue of access because we look over here, private string name. If we go to student and we re-implement our overridden, if we re-implement and instead of this, we say this, hi, my name is plus this dot name, we aren't allowed to access this dot name from the student because it is private in the person class. So now if we try to compile, we get an error where it says name has private access in person. Okay. What we can do instead is that we can either call getName, right, the getter method, or we can augment, we can specialize and extend the class using super. So we can say, like I did over here, we can say super.sayHello, and that will actually call the parent's implementation of sayHello. So if I remove this code, right, if I remove this code, let's just make it a bit more legible. We are now calling super.sayHello, which is in the person class. This is super.sayHello. And if we now compile and run it, you can see that it first calls, so this is person.sayHello or super.sayHello from the student, and then we add something to it. Okay. So this is how you can call parent methods or superclass methods when you're overriding them. And please, it's good practice to add an @override annotation. All right. So there's a quick fix. We can just use the getter. However, we want to make it a bit more secure, or at least a bit more elegant. So we want to work with our idea of encapsulation. When something is private, it is inaccessible, directly, you can't directly access it outside of the class, even to derived classes. And we must use getter and setter methods to interact with attributes of the superclass. However, there is a third access modifier. So we have public, private. I don't know why my writing suddenly went to, and protected. So this is the third kind of access modifier that we're going to learn about. And protected means that both the current class, so the current class, and the immediate child classes, so the student, if we had a person and a student, protected means that both of these can access that attribute in the parent. Okay, because it's protected. All right, so we've learned about private, public, protected. We have some rules when we talk about inheritance and encapsulation. This is mostly as a result of security and kind of data protection for your classes and making the compiler's job a little bit easier. When you are overriding a method, you cannot change the access modifier. So if you have a public method in the parent, so in the person, you have a public method, you cannot change it to a private method in the student. Okay. You cannot make this change. You also cannot make a private method in the person. You cannot change it to a public method in the student when you are overriding. Okay, that's just a rule. Java needs those rules because it needs to be able to compile your program. Private methods and attributes can also not be accessed anywhere else outside of the class. Okay, so if it's private in the person, it's not accessible in any derived classes or outside of the class in any other class that uses it. Methods can be both overridden and overloaded. So you can have say hello with a number of different parameter lists, right? So you can add like someone else, you can say another person, right? So you can greet like a different person. And then in the student, you can override any of these versions of the method, as well as further overload that method. Okay, so it's not, if you have overloaded a method, it doesn't mean you can't override the method as well. Overriding is explicitly superclass and subclass. Overloading happens when you change the method signature. Parameters can also be passed to a superconstructor. All right. That's most of the material. We're going to move on now for a little bit of more detail and then maybe touch on polymorphism. So we're going to look at some examples. If you have any questions, feel free to interrupt at this stage. We're going to do some more explanations. All right. So if we override a method in a subclass and call that method, we are unable to call the method in the superclass. So if we have say hello in both student and person, this one has the @override attribute, right? So this version of say hello overrides this version in person. So now in the scope of student, if we say this dot say hello, we are referring to this version. If we want to access, say the say hello function in person, we need to say super dot say hello. The same way we would call a superconstructor, we can call methods in the parent class by saying super dot. This is only in the case where we have ambiguity, right? So in this case, we might mean the parent say hello method. However, if you actually went and did this, you would run into an issue. What is that issue? Does anyone want to take a guess? So if you ran this code right here and you called say hello.
I don't know, sir.
Okay. So if you call say hello within itself, it's legal, but you will infinitely call yourself over and over and over again. So you've overridden the method in the subclass, and then you call that method within itself without making sure that you mean the parent class. Then it just does something called recursion. So it loops back in on itself, and it just keeps doing that infinitely. Okay. So
Oh, wow. Like it's...
Yeah, so what Java is doing here is it'll start executing, it'll reach this instruction, and this instruction says to go here and start executing. And then it will start executing, it will reach this instruction here, and it will start executing again. And so on all the way down. Until your computer runs out of memory and your program crashes. Does that make sense?
Yes, so basically it's like a while loop without the break.
Exactly. So it's exactly like a while loop without the break. This concept of recursion, right? So this is the keyword. This concept of recursion is actually very useful. There are some algorithms that use recursive methods to be quite efficient. So it's not always a bad thing, but unintended and infinite recursion is. So if you're interested in algorithms and a little bit more like functional programming or more advanced computer science topics, go have a look at recursion. It's a pretty interesting programming method. So people can use recursion instead of while loops and for loops. Okay, so to get rid of that ambiguity, we use the super keyword, just like we said before. We use super, and super helps us say, oh, you mean the method in the person. So as soon as the compiler reads extends person, it assigns the super keyword to person. Okay. So it assigns this super keyword to mean person. And so then in your code, whenever you use super, it knows you mean person. The same way that when you say class and you give it a name, it populates what this means for this context. All right. So that's a little bit of ambiguity when we're overriding methods. However, there are limits. Like we said before, you can only access the direct parent of a class with super. You cannot say if we had something like an undergraduate student, which extends a student, and we wanted to get to, so now we have a person, right? And this is the person class. We have a student, right? And this is the student class, and then we have a undergrad student. So an undergraduate student extends the student, and a student extends the person. In normal English, this essentially means an undergrad is a type of student and a student is a type of person. However, we can't say super.super to get to the person say hello. We can't skip over like this. You can imagine there's like a little invisible boundary between everything, and the undergrad is prevented from going further than the direct parent. Okay, that drawing's a bit bad. So if we have person, student, and undergrad, we have these boundaries. The undergrad cannot go further than the direct parent. All right. So you need to think of things in terms of direct relationships between classes and direct relationships between these classes. And so that's where the encapsulation comes in, right? So if you have encapsulation, the data can be passed between these two and is controlled how it's being changed. And the data can be passed between these two and is controlled how it's changed, with the idea being that if we've thoroughly tested these two, right, we can forget about them and then start testing these two, because the data exchange is correct here. So we can continue building on into more and more complicated systems without having to worry about it affecting everything up the chain of inheritance. Let me just double check any comments. Seem to be okay. Is everyone still with me? Are you surviving?
Barely.
Okay, barely. We'll recap some of this then tomorrow. These are all
like sir is explaining it properly, but just the amount that you're explaining.
Yeah. So it is a lot. I'll recap this tomorrow, and maybe we should have a bit more of a discussion where you can ask me things that are unsure, or things you are unsure about, or things that don't quite make sense. It's a lot of information, but once you get it, it'll all make sense. Programming languages, or the good ones at least, have to be consistent and reliable. So the rules will always be the same. So I think actually it's now 1:45. I think we'll stop there. I'll make a note of the slides we stopped on, and we will pick up tomorrow from here to give you a chance to absorb this information so that I'm not overwhelming you. Yeah, so let's open it up for any questions or queries or anything.
Yeah, so I see you released a quiz 1.
Oh, yes.
Yeah.
Yeah, so quiz 1 is your first quiz of 4th term. I need to make an announcement. Thanks for reminding me.
Now, don't forget the error in the code.
Yes, I'll announce both of them. Quiz 1, it's 15 marks. It's related to exceptions. There's 2 questions on exceptions, and the rest is like very basic object-oriented programming. You get 2 attempts.
There's a code there's a multiple choice thing.
No, it's all multiple choice and fill in the blank.
Oh, okay, I see.
Yeah. So it's you have 2 submissions. We'll record the highest one. The first submission is for you to see what you don't know and then go and look it up. I think the question order might be randomized. I'm not sure. But
also must we type in a code, not select a code?
Oh, no. It's just fill in the blank and then multiple choice. So fill in the blank would be a method can be, a method signature consists of.
Okay.
Yeah.
I see.
Yeah. So it's to test your knowledge. And you'll have 1 week. So from now until next Wednesday, you have 2 attempts. Yeah. I'll make sure to put it in the announcement. Yes. And then next week, Wednesday, I'll release another quiz.
Yes, sir.
Okay. So if you find you really don't understand the concepts when you went through the quiz, you have to get in touch with the tutor. Or you have to ask me. Yeah. We're not testing everything. We're just making sure you know what you're doing. All right. Any other queries, questions? Tomorrow we'll start with polymorphism. Go ahead.
Are we gonna have a quiz, an assignment?
Yeah. So assignment 3 will come out on Friday.
Okay, so.
Yeah. Someone asked, or someone requested, can I upload the resources sooner? Yes, I'll make sure to do that. I also add them to the lessons tab, so they should be up on the lessons tab. Any other questions? It doesn't have to be related to the work. It can be related to assignments or the running of the course or whatever.
Hello. I have a question about the assignments.
Go ahead.
For the run assignments.java file, task 2, I guess this is when we are loading the cargo with items. It says delivery CA1 dot load delivery. So do we have to create a delivery method?
Yes. So let me just open the thing over here. Assignments. Just increase it a bit. Assignment 2. Are you talking about down here, load delivery?
Yeah.
Okay. So there's another thing here. Load cargo versus load delivery.
Okay.
So thank you. I will make sure to add that into the corrections.
Okay, thank you.
Akib was gonna bother me with that tomorrow, I'm sure.
Yeah, out of get the answer tomorrow. I was flipping.
Yeah, thank you. I really appreciate it when you guys. It tells me you're being diligent about your code, which is a good sign.
Yeah.
Right.
I was supposed actually if I should doubt myself or doubt I'm gonna go both ways.
I encourage you to doubt me. This is you're doing a degree in computer science, and as part of science, you must doubt and verify for yourself. So question everything. It sounds scary, but just do it.
Okay.
All right. Any other questions? Okay, if there are no other questions, I'm going to stick around for the next few minutes to answer any more queries, but I think for now I'll stop the stream I'll make sure to upload the resources and put out the announcements for you. Otherwise, have a nice afternoon. I'll see you tomorrow for another lecture. We'll recap a lot of this, and then we'll talk about polymorphism and how types work with inheritance.
Okay, sir. Thank you, sir.
Excellent. Have a nice afternoon.
Enjoy your day.
You too.